I can feel the energy in the room. Thank you all for sticking around. I know it's always a long one with conferences, but this one is short and sweet, I promise. So as Ethan mentioned, I'm Hugh. I am a developer advocate at Aiven, where I help to look after our Apache Kafka community. And I'm also an organizer at AI Signals and PyData London and some other meetups. And I'm a recovering platform engineer. Aiven, the company I work for, are a managed open source services company. So if you've used Kafka, Postgres, MySQL, Valkey, a lot of what we do will be familiar to you. We take open source software and we deploy it on the cloud of your choice, and we manage it for you to kind of abstract away some of the complexity. It kind of becomes like a turnkey service for data technology. As I mentioned in a previous life as a platform engineer, I spent a lot of my time operating Kafka at very large scales. So, the Aiven Kafka product is one that sort of makes a lot of sense for me. And would have saved me a lot of headaches when I was still doing platform engineering. So kind of a whistle-stop tour of what we're going to be looking at today. We're going to be talking about what Apache Kafka is for people who aren't familiar with it. Talking a bit about the work that Aiven and others have been doing to bring diskless to Apache Kafka. And a little bit about diskless Kafka at Aiven. First things first, though. How many people here are using Kafka? Like, anyone using MSK? Cool. So, Apache Kafka is a distributed event streaming platform. It's kind of, if not the standard, then at least the most popular way of doing event streaming is via the Kafka API. And as I mentioned before, Aiven provides a fully managed service version. Apache Kafka was open sourced by LinkedIn back in 2011, and since then it's become this kind of industry incumbent. Like 80% of Fortune 500 companies use Kafka for event streaming. You may be familiar with like pub/sub as a model of events, where you produce a message and you consume a message, and then it's gone from whatever service you're using. The key difference between Kafka and pub/sub is that Kafka is a distributed log. So the message remains in Kafka for a retention period, which is very useful if you have issues or you want to replay data later on. When I was still the kind of person that was getting phone calls to wake me up in the middle of the night when things went wrong, we would set our Kafka retention to 3 days because it meant that something could go wrong over the weekend and we didn't have to worry about it until Monday, which was pretty sweet. So 2025 was an interesting year for Kafka. We were introduced to this thing called diskless, which we're going to be talking about in the rest of this presentation. But it's kind of a new way of building Kafka that makes it cheaper and more flexible. So a company called WarpStream launched it. I didn't make this meme, but someone else argued that everyone else copied WarpStream. I differ slightly on that, but everyone copied WarpStream. Confluent, who are the people who left LinkedIn after they open sourced Kafka and were the biggest Kafka vendor in the world pretty much, they bought WarpStream. Some of my colleagues at Aiven worked on starting to release an open source version of diskless. And then IBM bought Confluent, completely upending the entire industry. So like, if you don't know what diskless is, you can see that like the ramifications of it have been pretty significant. So what actually is diskless Kafka? So diskless is an umbrella term for various implementations of the Kafka spec, which eliminate local disk, hence the name, in favor of object storage for storing data from Kafka. So typically in Kafka, your data, when you produce it to the cluster, is written as a partition, written into a partition on local disk, and diskless is writing it to object storage. Now, like, why do that? So to understand why diskless is so important and has been so disruptive, we have to talk a little bit about how regular Kafka works. So when you write a message to a Kafka cluster, typically it's replicated between a number of other brokers. So Kafka is like a distributed model. The reason for that replication is because it supports greater throughput. If you have multiple nodes with copies of the data, when you go to consume or read that data, you have more places to do it from, so it can reduce latency. And also because of reliability. If your data is replicated 3 times, you're not going to lose it if you lose a single broker or a single disk. But as with most data services now, Kafka is typically deployed to the cloud, and as I'm sure everyone in this room is familiar, whenever you move data between cloud availability zones or out of the cloud and onto on-prem or vice versa, cloud providers tend to charge you pretty significantly. I think the last I checked, it's like 15 cents a gig for MSK egress or ingress at the moment. So, it's very expensive to replicate this data. So what diskless does is eliminate this cross-zone network traffic where you're replicating partitions between brokers, because when you write your partitions to object storage, when you do an object storage put instead of an IOPS, you don't get charged for replicating across zones. So AWS don't charge you for replicating between S3 buckets, and also the level of replication you need is significantly reduced because object storage has like 6 nines of reliability. So I don't need 3 or 4 or 5 copies of my data. I can have like 1 and probably get away with it unless US East 1 does something interesting again. Another interesting aspect of diskless, aside from the fact that it eliminates all of this cross-availability zone cost, is that it becomes leaderless. So in our original model of Kafka, we have a leader broker who is responsible for receiving the message initially and replicating it out to all the other brokers. And that broker is also responsible for things like maintaining strict ordering, checking how many times a message has been consumed, and ultimately making Kafka able to do all the enterprisey things that it's been known for and can be relied upon for. In diskless, you don't need that leader anymore, potentially, depending on how you implement it. You can shove metadata in your object store, and because your object store is sufficiently reliable, you can use that. And there are like a few different approaches. But removing the leader from the equation means that if you horizontally scale your cluster, if you add more nodes, you don't have to do a full rebalance where all of the partitions that every broker knows about have to be swapped around and moved around. And instead, you can just add and remove nodes much more quickly. So that's also a very appealing thing. So we have these 2 main reasons why we should care about diskless if we're doing streaming, cost and flexibility. If you aren't already familiar with the Apache Software Foundation, they are this enormous open source project, which many of the kind of older is probably not the right word, but many of the projects of the 2010s have ended up managed by the ASF, including Kafka. So with diskless being this huge transformative cost-saving flexibility thing for this most popular of streaming tools, lots of people were rushing and working to get diskless into open source. So it wasn't just locked behind the paywalls of vendors. Such was the disruptiveness of diskless that there are actually 3 different attempts to do this. So this is a quote from Luke Chen. He is a committer on the Apache Kafka project, and he did a really good job of summarizing it by saying that the Kafka community was in an unprecedented situation with 3 KIPs. So a KIP is a Kafka improvement proposal. It's basically just a kind of a formal suggestion for how to steer this project. Because Apache Kafka was open source in 2011, that's done exclusively via mailing lists, which makes it very confusing. But if you read the runes, you can kind of figure out how this conversation evolved. And all of them address the same challenge of high replication costs when running Kafka across multiple availability zones, which is the key problem that diskless addresses. To kind of understand the solution that we've landed on as a kind of a community, I'm going to walk through those 3, and hopefully that will make more sense of kind of where we are now. So KIP 1176 was from the team at Slack. It was, I believe, called hot writes for tiered storage. So in Kafka, you have this concept of tiered storage where you set your retention period. So you're like, oh, I produced a message to Kafka. Now it's going to stay in Kafka for 3 days. With tiered storage, you could say at the end of 3 days, move that message to object storage or to some other kind of storage which is cheaper than local broker, and then I'll use it for like analytics or ingestion or batch stuff later. The team at Slack basically looked at that and went, hey, why don't you just push the point at which you write to tiered storage much earlier in that process and skip the intermediate step entirely? This was a pretty cool proposal, but it did retain the existing leader model. where the leader is responsible for ordering messages. So yes, we get some of the cost savings, but we don't get that flexibility, which is like another interesting promise of diskless. An upshot of this is the way that tiered storage works in Apache Kafka is it's entirely mediated by this component called the RSM, the remote storage manager. I don't know if you've made open source contributions, but the idea of like a big change like this being like, it's like one file is very exciting, like super, super simple, much easier to get approved than other proposals. Then there was KIP 1183. This is from the team at AutoMQ, which you may also be familiar with if you're in the streaming space. But they had this really interesting proposal to add a new storage layer abstraction. So effectively, Kafka would go from having this sort of default storage method of writing to broker disks, and instead it would have a pluggable backend. So you could put object storage there, you could put Postgres there, you could do all kinds of weird and wonderful things. It would have pluggable leaders, so you could use different leadership models. And the way that your Kafka messages are ordered, which is a really important part of operating a Kafka cluster, would depend on your implementation. This was super exciting, but their proposal only specified the different new APIs that would be added. It didn't actually specify an implementation for the storage backend. And then there was the one that my colleagues at Aiven released, which was just around the time that I joined. So this was a fully leaderless architecture, which replaced the concept of a leader with multiple coordinators, which kind of assume some of the responsibilities of the leader, but most of the responsibilities are just assumed by the object store. So it's leaderless. Any broker can write to any topic or any partition within Kafka, which gives you that flexible scaling. And you have this coordinator, which is responsible for sequencing messages. And you can have multiple copies of the coordinator, which was super interesting. This was not accepted when it went to vote because it was a 10,000-line code change. And the Kafka community went, I'm not reading that. So it was back to the drawing board. So as of kind of the end of last year, that was the state. And now we're in this interesting place where the 11.7.6 team kind of threw their hat in behind 1150, and the two authors of both KIPs worked together. So 1150 was reduced in size by adopting this approach of adding diskless via the RSM, and the 11.7.6 KIP was withdrawn in favor of KIP 1150 because 1150 does all this cool leaderless stuff. And unfortunately, the AutoMQ proposal just kind of petered out. Like no one contributed to it, no one added any comments on it, which is sad because I think it's really cool. But then I am someone who has to care about Kafka for a living, so maybe that's just me. But I thought it was interesting. I hope they bring it back. So we, and when I say we, I mean my colleagues at Aiven, restarted the vote on 1150 after adopting these changes from the team at Slack, and the KIP was adopted. Now, because open source is big and complicated and important projects like Kafka have very thorough vetting processes, that KIP getting adopted does not mean that diskless is in open source Apache Kafka. It means that at some point in the future, it will be in Apache Kafka, and that is probably a years-long process. But as I said before, Apache Kafka is used by like 80% of Fortune 500 companies. You can't afford to have breaking changes. So it's come in very slowly. In the meantime, what the team at Aiven have done is release an implementation of the proposal as Inkless, which is this kind of like code name for their implementation of 1150. This means that you can go and like pull this fork of Apache Kafka, you can try it out, you could run it self-managed if you were feeling brave, and kind of play around with diskless. It's all on GitHub if you want to check it out, and I can share links afterwards. So yeah, Inkless Kafka is just KIP 1150. KIP 1150 has evolved a lot since it was adopted and in the process of being adopted. But Inkless is just kind of the name we've been using for it internally. We're actually killing the name Inkless pretty soon because we're fairly confident about making a lot more progress to getting this into Apache Kafka, at which point you can just call it Kafka. You know, it's an upgrade rather than a migration, as my boss is fond of saying. We've done some very extensive benchmarking on our implementation. You can see the full results on the Aiven blog. And yeah, it's pretty good. You're writing to object storage, but something that is really worth calling attention to, and is kind of the crux of this conversation, is that latency at the bottom. Now, if you don't know about Kafka and streaming, you might say, oh, hey, half a second of latency, that's fine. But no, typically in Kafka, latency is like 100 milliseconds, 200 milliseconds or less. So, we've come out here, we've built this diskless thing, and it's 3 times slower, 4 times slower than state of the art. What's up with that? So this is the fundamental trade-off with diskless, and this goes for all diskless implementations, not just for Aiven Kafka, is that object storage puts are just always going to be slower than writing to disk. So that's kind of an unavoidable problem, right? Like, you have those network hops, you're reliant on whoever is providing your object storage to meet their SLAs. We did a bunch of testing. Effectively, we ended up testing S3 to see how fast it went. And in P99s, we were seeing like 2 seconds of latency sometimes, which is crazy. But it means that diskless Kafka is always going to have a high latency. So to avoid that, in our implementation, we added the idea of classic and diskless topics. So classic topics still write to local disk. They're very fast, but they are more expensive. And if you want to increase the size of cluster with classic topics, you have to wait for them to be copied around and rebalanced. And then you can have your diskless topics in parallel to them that write to object storage and are configured through the RSM that are significantly cheaper but a bit slower. Now, because we operate a very large number of Kafka clusters for our clients, we know what people are using Kafka for. And most people are shifting about a megabyte a second of data, and typically they don't have requirements for latencies of less than a second. Like, if the thing at the other end of your streaming pipeline is a person, you probably don't need sub-second latency unless they're like super quick. So we're confident that diskless is going to work well for a lot of people. You're able to have this model where you have both topic types in the same cluster because the 1150 implementation just maintains the Kafka APIs. As far as your producers and consumers are concerned, your clients are concerned, you're just talking to Kafka. It just happens to be a bit slower than usual. And yeah, many use cases can tolerate those higher latencies, but if you're doing like real-time kind of trading or gaming applications, you're going to want classic. This is something that we are providing as a managed service at the moment, if that's of interest. Currently, it's called Inkless. It's going to be just called Kafka on our platform pretty soon, but you'll have a switch to flip, which is like, hey, I want things to be cheaper. And who doesn't, and yeah, it is much faster at scaling because we avoid that rebalancing issue. But I think one thing I've not touched on is, obviously, throughout the duration of this talk, I've been going like, oh, it's cheaper, it's cheaper. It's 80% cheaper. That's how much AWS and other cloud providers charge you for that replication. So it's an enormous cost saving. When I was was consulting at Sainsbury's on their Kafka deployment, they were getting bills of like 35, 40K a month for Kafka. So 80% saving on that is very significant. And yeah, the rebalancing, obviously I'm an engineer, cost savings are great, but that's kind of above my pay grade. But the rebalancing is awesome. Like, you go from rebalances taking like hours or days for very large clusters down to like minutes. And that's pretty great because you don't have to sit up all night babysitting a Kafka cluster as it scales. And yeah, so this is something that we benchmark pretty extensively. Also, because you have that faster scaling, DR is faster. Like, you can kick over a node and a new node can replace it much quicker. So yeah, all in all, a much more pleasant system to operate. So yeah, takeaways here are you have potentially an 80% cost saving on your Kafka cluster by removing that cross-AZ replication. You still have some replication of like metadata for ordering, but for the most part, that cost is eliminated. Inkless Kafka is KIP 1150, is diskless Apache Kafka. We're trying our best to kind of consolidate that all into one name, having spent a lot of time talking about it now. Diskless Kafka topics do have high latencies, sometimes 2 or 3 times higher, but if you can tolerate that, you can save a lot of money. And our implementation supports both classic Kafka and Inkless Kafka. It's all available now on Aiven. Something that we're very excited about, though, is something kind of building on this. So if you do sort of like what AutoMQ was saying, where you have these kind of pluggable storage backends, so you have now these two topic types, one for classic and one for diskless, maybe you could have other topic types. Maybe you could put more interesting things into a Kafka broker that lets it talk to more downstream systems natively. So we know, again, because we operate a very large number of Kafka clusters, that something like 85% of Kafka messages end up in a data lake. And as we're seeing increasingly, those lakes tend to be iceberg-based, with your messages materialized in Parquet and then doing lots of cool stuff on top of that. So one of my colleagues, Anatoly, has been looking into building iceberg topics, which take the code for diskless Kafka and then extend it such that you can write in Parquet. Now, this is really complicated. The main reason being that Kafka messages are in a format called Avro, which is row-based because you have individual messages and you have fields and you serialize it and then you transmit that. Iceberg, as a Lickhouse format, is columnar, where your data is stored in such a way that you can easily do aggregations. Those two things do not want to talk to each other. Iceberg is slow, Kafka is fast. It doesn't work. So to make that work, you have to deserialize your Kafka messages. You have to batch them up, convert them to Parquet, and then push them into Iceberg. So this is something that is technically possible. I've seen it done. It's very cool. It is kind of a party trick at the moment. It feels like magic because there's a lot more work left to do. So this is something, again, we have an open source version of this. You're welcome to go and play with it. Please do not put it into production for the love of God, I beg you. It can't do schema evolution. It's very complicated. But this is something that's possible. Right now, this is traditionally mediated by some kind of ETL tool that reads from Kafka and pushes to Parquet. But this is something we're working on and we're very excited about. Potentially, there's a future for other topic types, writing directly into downstream systems, where effectively you're eliminating these additional services, these sidecars that do conversions, and just plugging Kafka directly in as this kind of beautiful piece of data plumbing between all of your services, which is pretty neat. Thank you very much. That's all from me. If you want to try diskless Kafka, you can go to Aiven.io Inkless. There's open source and managed to play with. And yeah, if you have any questions, give me a shout. Thank you for listening.